Wind moves horizontally from high to low air pressure. Whether it moves clockwise or counterclockwise depends on the hemisphere and the pressure. In the northern hemisphere, in a low pressure zone, we see counterclockwise movement, and in a high pressure zone in the northern hemisphere, we see clockwise movement. Same goes for the southern hemisphere. In high pressure zones, we see counterclockwise movement, and low pressure brings clockwise movement. The Coriolis effect is the idea that because of Earth's rotation, wind appears to be curved when looking at it from a non-fixed frame of reference. The Coriolis effect does not affect the wind speed, just the direction. What we expect, like the picture demonstrates, is for the wind to blow straight. It's like when we see someone walking down the street, they appear to be, from our point of view, walking perfectly straight. But in reality, they are walking in a curve since the Earth is round. It's the same with the wind. To us, it appears to blow straight lines, but it actually curves because of the Earth's spherical shape. Again, depending on the hemisphere, the wind will curve different directions. For example, in the northern hemisphere, in a low pressure area, the wind curves off to the right, but in the southern hemisphere, in a low pressure area, the wind curves off to the left. You can also see it illustrated in this picture. You can see in the northern hemisphere, objects deflect to the right, and then in the southern hemisphere, objects are blown towards the left. Low pressure systems rotate counterclockwise in the northern hemisphere, causing air to converge near the ground. Since there is nowhere else for the air to go at that point, the air rises, cooling the higher that it gets. As the water vapor cools, it produces clouds, and then rain once the clouds become too heavy. This is why low-pressure systems are often associated with stormy weather. High-pressure systems in the northern hemisphere have clockwise rotation with air diverging or moving away. High-pressure systems are associated with good weather because air fills where the other air has diverged, creating sort of a sinking motion at the center of the system, leaving us with nice clear air and a beautiful day. Lastly, the position and region relative to the circulation cells and wind belts determines the type of climate it will have. Because the Earth's surface is not uniform, equal pressure belts do not exist. For example, the intertropical convergent zone, a low-pressure area near the equator, has air that rises and cools as it does so. It cools as it does so, creating clouds and rain. The climate there is warm and wet nearly all the time. Also along the same lines, this is why Oklahoma is so susceptible to tornadoes, because the warm Gulf air and cool Arctic air meet, clashing with different air masses, creating a front, which is just the condition needed to form a tornado. In the middle latitudes, we see the typical west to east flow of westerlies interrupted by the migration of cyclones and anticyclones. Therefore, depending on where you live, you will experience different weather patterns and climates.